In the 1980s, Iran and Iraq were in a war, commonly called the Tanker War. During this war, Iraq would send a civilian jetliner called a Falcon 50 small business jet along the coast of Saudi Arabia, bordering the Persian Gulf, to conduct reconnaissance missions masquerading as a civilian flight. It used civilian flight paths, flight plans, and was essentially a civilian flight conducting a military reconnaissance mission along the edges of the Persian Gulf. During this time, it would take photos and conduct identification of tankers and their positions in the Persian Gulf for later attacks. Well, a general in the Iraqi Air Force convinced Saddam Hussein that it would be a good idea to send one Falcon 50 business jet to France for a modification. The modification would be to install a Mirage C5 radar on the nose and two weapons mounts, one under each wing, capable of holding Exocet missiles. The idea was, as this Falcon 50 business jet conducted its reconnaissance, it could also attack the targets that it's finding in real time. And that would lessen the time between identification and attack. And it's masquerading in disguise of a civilian airliner the entire time. This is what is happening on 17 May 1987 in the Persian Gulf, as the USS Stark is operating in the vicinity but south of the exclusion zone between Iran and Iraq, off the coast of Saudi Arabia and Kuwait. This jet is being escorted by two Mirage jets to the Iraqi border when the Mirage jets break away, and this jet continues along its civilian route, masquerading as a civilian but armed with two Exocet missiles. This jet is on the radar of the USS Stark at this time. It's after 2000. It is late in the day. The sun is setting, and this jet believes it has found a target that it wants to attack. The target that it sees is the USS Stark. He believes it's a tanker. So he turns out of the civilian jetliner path that all the other civilian jetliners are using and begins approaching the USS Stark. The Stark sees the plane coming at them. The plane has an identification beacon required by all civilian planes to identify itself, and it is identifying itself as a Falcon 50 business jet. The jet continues to close the USS Stark in a direct path. It's going to fly right overhead. When the captain of the USS Stark has his radio operator get on communication with the approaching aircraft, asking it to identify itself. They get no response as the jet quickly begins to close now. And at 22 miles away, it looses one of its Exocet missiles at the USS Stark. It continues to close an additional 7 miles to 15 miles away. This is very close, and shoots the second Exocet missile. The USS Stark radar sees the plane the entire time. The plane turns away back towards Iraq, but they never see the incoming missiles. The first people to see the missiles are the lookouts, who raise the alarm only moments before the first missile hits. The first missile hits the forward end of the superstructure of the USS Stark and thankfully does not explode, but it has a large rocket motor with rocket fuel, creates a terrible fire that burns all the way into the CIC command and control space, which knocks out the Stark's ability to fight back at that point. Moments later, the second Exocet hits nearly the same location, but this one does explode, ripping through the crew's quarters, killing 37 sailors instantly, injuring over a dozen more. It is found later that the close-in weapon system that would have defended the USS Stark from these missiles was in a standby mode. It was turned on, but it was on safe, essentially, where it could see targets, track targets, but it wasn't going to engage targets. So the one chance the USS Stark had to defend itself with the weapon system designed to shoot down incoming subsonic cruise missiles was not even in play. It was put on safe. But miraculously, the USS Stark did not sink. The crew rallied together, put the fires out, counterballasted the flooding, and managed to get the ship back to Bahrain under auxiliary pod power. This is a testament to the engineering design and durability of the Oliver Hazard Perry class and the crew's training and ability to fight the ship. They saved the ships from sinking through their training and the design of this ship. This is the story of the Oliver Hazard Perry. Let's begin by going over my sources. Again, a big thank you to Mr. Saturnax on. All right, let's go. So the Oliver Hazard Perry begins in 1970 under the name Project 60. The Chief of Naval Operations, Admiral Elmo Zumwalt, is scrapping about 190 World War II destroyers and escort ships because they're getting old and they're no longer tactically viable, and they're taking up a lot of manpower and resources, money, to keep them afloat and maintained. So doing a massive scrapping of old ships, and they want to use that money that they're freeing up to start a new program, to build a new ship. And that's what Project 60 is. It's a 50-ship program designed to provide self-defense, long-range escort, ASW, and air defense duties for high-value supply ships. So there was a tactic during the Cold War that NATO had called Reforge, which was reinforce Germany. Part of that was to get troops, equipment, and supplies from the east coast of the United States to Germany in under 7 days. To get across the Atlantic, get loaded, across the Atlantic, unloaded in 7 days to help fight a war with the Warsaw Pact should the Cold War ever turn hot. Well, in order to escort these supply ships, even after the 7 days and going on into the future, they needed a fast escort vessel. And that's the primary role that the Oliver Hazard Perry ship was going to provide. Now, President Nixon's domestic focus administration, which was very popular at the time, he was ending the war in Vietnam. He was focused on a domestic agenda, but this also meant that there was very little money for the Navy or any of the other branches of service, as he was focused more on America itself. And by the way, Nixon at that time, very popular president, doing this. You know, he was ending the Vietnam War, which was a big thing, and then other programs were very popular. But this resulted in a ship that had to be designed based on value. In other words, they had to make cuts not on capability, or they had to cut capability just so that they could afford to build a lot of these ships at the least amount of cost possible, but still have an effective warship in the end. And that was a delicate balance that Project 60 was trying to resolve. So this is the first design to cost procurement. And also, as a side note here, this is also only the second ship the U.S. Navy ever built first entirely on computer before they ever started cutting steel. So they're using new technology for the time to save naval architecture and design timelines. So they're going to design this one quickly and then get building right away. 1971. Okay, so with the limited funds we talked about, they're only going to focus on anti-air and anti-surface capabilities. The sonar system that they ended up going with was a scaled-down version of the one used on the Spruance class destroyers. So they thought the idea was the Sprue cans can do the long-range ASW search, and we're going to have this fast frigate with a long-range anti-air radar to be a picket ship, and then we're going to give it helicopter capability and a sonar system, but it's going to be a high-freak, short-range sonar system compared to the Spruance one to provide escorts. So the Mark 13 launcher could fire both harpoons and the standard surface-to-air missile, which is the Navy's SM-1 missile. The Mark 46 torpedo launcher could also fire Mark 50 torpedoes, and they're giving it a 76 millimeter cannon, which has an odd placement on top of the superstructure midships. And so that kind of limits its range of fire. It can fire to the sides as if it were like a broadside in an old ship. It doesn't have forward or aft firing capability. The ASROC launcher was removed to make room for the Mark 13. So it doesn't have the long-range ASROCs that other ships had. The SPS-49 air search radar and the SQS-56 high-frequency sonars are used. And SLQ-32 electronic warfare system is added. Those are the large antennas that you'll see on the back of the superstructure near the helicopter hangars. And the close-in weapon system, CIWS, is mounted above the helicopter hangars. Now, the helicopters that they're going to use are the SH-2 Sea Sprite or the SH-60 Sea Hawk. And there are going to be two versions of the OHP that are built. There's the short version, and then there's a slightly longer version. that has the larger helicopter. Something that's unique to this build is they're going to build the ship in modules. There's 16 total modules, and any shipyard that's capable of building a warship can build one of these modules. This added a lot of flexibility in the event of war. If one shipyard was destroyed or damaged, the United States could use any of its shipyards around the country to build any of these modules. And then you just bring the modules together and assemble your ship. So a very creative computer-aided drawing, module design for creating the Oliver Hazard Perry ship. So here's the line drawing of what they came up with. Very efficient design. It is a 4,100 ton ship, and that ends up being a small problem. Is it was originally designed to only support 3,900 tons. So because after they got all the equipment on it and the antennas and everything, ended up being 4,100 tons, it made it slightly unstable. And there's two different lengths to these ships too. And they built these at the same time. You got 445 feet is the short one. That was FFG 7 was the first one. And FFG 8 was the first long haul, 453 feet long, 453 feet long. Both are about 45 feet wide. They use LM 2500 gas turbine engines. So this is only the second ship to use the gas turbine engines at the time. There was one other one. She can do 21 knots at 41,000 shaft RPM. She has a range of approximately 5,000 miles. It's a little bit generous, if she only goes around at 18 knots and kind of a fuel saving mode. She can carry 587 tons of fuel and 64 tons of aviation fuel for the helicopters. She carries 2 lamps capable helicopters. And the lamp system is a little bit different for the Sea Sprite than it is the Seahawk, but they have the same mission, which is basically over the horizon targeting and searching. So they have they have ASW capability on these helicopters, but they also have a surface search radar on the helicopters, giving this ship over the horizon radar capability. There's 185 crews and officers. Other nations that use this ship, like the Australians, have over 200 crew and officers on the ships. So these are very crowded ships for their size. All right, so the shipyards that are building these. Well, the first contract is awarded to Bath Iron Works in Bath, Maine. It's a $94 million construction contract. She gets to build the first one. 1975, construction begins with the lead ship, so the design process is finished at this point. And using that design, another contract is awarded to the Todd Shipyard Corporation, where they're going to build ships on the West Coast at San Pedro, California, which is kind of a part of a Los Angeles greater area, and Seattle, Washington. They're going to end up building 25 short hauls and 30 long hauls. 4 of the short hauls will end up being built for Australia, and the longer hulls will use the larger helicopter, the SH-60 Bravo, with the LAMPS 3 capability. That's a little more capable than the LAMPS 2 with magnetic anomaly detection and Mark 50 capability. And we'll show you that. All right, so let's take a look at the Oliver Hazard Perry class frigate system. So we're going to begin at the top left of this diagram and follow it through this slide here. So we're going to begin with SPS-49 air search radar. That's the long range, large mast, centrally mounted rotating radar that you see. They have the SPS-55 surface search radar, and that all comes in to the electronic warfare system and the fire control system that kind of links all these systems together. The Mark 92 fire control system is extremely important, as it is basically the central hub that all these informations get collected into and then sent onto the weapons. That's kind of the flow of information. So we're beginning with the radars and the high frequency sonar down there at the bottom, feeding into the weapon system, and then that information is passed on to either the torpedo or the harpoon system or whatever. They have the Mark 36 decoy system and a tactical towed array sonar system, also called TACTAS. So here's some pictures of the combat information system. Very spacious. This room and battle stations would be very crowded, but there you can see the tactical plot in the center. They have the surface search radar and the air search radar there. The cabinets that you're seeing there at the top are the IFF system and the radio comms is there on the right. You can see multiple red encrypted telephones there for encrypted communication. And that typewriter is actually a printer that prints out messages that are encrypted. So they come in plain English as they come across the printer there. Here you can see some crew members operating the equipment that we're talking about. SQS-56 sonar and the tactical towed array TACTAS are two consoles that are adjacent to CIC. They have their own little space. Here you can see the Chief Petty Officer is operating the towed array system. He is he's looking at what is called a LOFAR-gram, low frequency analysis and recording gram, that shows him narrowband information on the target. For the time, this is state of the art. Let's go back to the diagram and take a look at the lower half. The lower half talks about the weapon systems. So the Mark 13 Mod 4 guided missile launcher holds standard missiles and harpoon missiles. It can hold up to 40 of these. It's got two Syndrolic magazines, one around the other. The inner one holds 16 missiles. The outer one holds 24. A total of 40 missiles. We have two triple Mark 47 torpedo mounts, port and starboard side. Have one 76 millimeter Mark 75 rapid fire gun, a phalanx close-in weapon system, which is a 20 millimeter Gatling gun, and an SH-2G Lamps Helo, or with the long haul, an SH-60 Bravo Lamps 3 helicopter. So the Mark 13 guided missile launcher system, designed in the 1960s, shoots a standard missile. Standard missile can be loaded every 8 seconds. So it's much faster than the harpoon that takes 22 seconds to load. So I mentioned that the magazine has 40 missiles essentially, but one of those missiles always has to be a training round. The training round is what you're looking at there on board Australia's Adelaide ship. It is blue in color, and they need that mounted to conduct weapon systems tests on the electronics inside the system itself. They don't ever want to run a test with an actual missile because, you know, if something goes wrong, you may actually accidentally fire it. Well, this dud training round cannot be fired, but it completes the fire control circuit for circuit testing, essentially reducing the effective magazine to 39 missiles from 40. The Melara Italian 76 millimeter rapid fire naval gun is a 1964 design. It can shoot 85 rounds a minute, which is pretty good. It has a range of 16,000 yards if they're shooting the HE shells, and an 80 round magazine. The magazine is a Syndrolic magazine, like you see there, the sailor is loading up. It can fire different shells as well. HE is not the only choice, and the other shells that are armor piercing can reach out to 20,000 yards. But if it's shooting the HE round, which is the most common round and the least expensive round, it's about 16,000 yards. The Mark 32 surface vessel torpedo tubes, or SVTT, are triple mounts on the port and starboard side. They are 12.75 inch, 324 millimeter torpedo launchers, and they shoot both the Mark 46, Mark 50, and they can shoot the Mark 54 now after the midlife upgrade. We'll talk briefly about the midlife upgrade later on. The Mark 54 torpedo is essentially a Mark 50 guidance system with a Mark 46 engine. It is because the Mark 50 is so expensive and it's very capable. It's extremely fast, deadly as hell. You don't want to have a Mark 50 chasing you. But because it's so costly, they don't want to build a lot of Mark 50s. You know, if you can destroy the same less capable submarine with a Mark 54 and save a little bit of money, they'll use the Mark 54. That's the idea behind having 3 types of torpedoes. So Mark 46 is the oldest, least capable, has a reliable engine though. A Mark 50 is top of the line, best engine, best guidance system, fast as hell. You're not running away from a 50. And so, but it's also the most expensive. And so they just took the best economic part of the 46 and the guidance system, which is, you're not dodging that, of the Mark 50, and put them together, called the Mark 54. And it's a good balance of the two. The Mark 50, to give you an idea, is designed to chase down the Alpha that does like 40 knots. It can chase it down and kill it. So it's extremely fast. It does a lot more than that too, but we're not going to get into that. All right, let's talk about the Phalanx close-in weapon system, 20 millimeter, 1969, designed by General Dynamics. Very common. You see these on all the American warships now. It's also sold to other navies around the globe. Very prevalent design. A lot of other nations have their own versions of this, but this is the American version. It's an M61 Vulcan Gatling autocannon. Is the type of mount that it uses. It's completely self-contained. It's not connected to the fire control system at all. Like, especially in the example of the USS Stark, where the CIC was hit by the first missile and set on fire, this system was not affected by it at all. It would have worked had they had it armed, but it was in safe mode. It was powered on in safe mode. And so while it saw the missiles come in, it didn't do anything about it in the case of the USS Stark. Completely self-contained, has a 5 nautical mile range, looses about 4,500 rounds per minute, which is an insane rate of fire, and just basically puts out a wall of lead there that runs into any kind of incoming missile. The Mark 38 naval gun system is a gun system that was installed on the O.H. Perrys after their midlife upgrade. This was designed for ships that were going to be stationed specifically in the Persian Gulf, but it was installed in other ones as well. It's a Mark 242 Bushmaster design. It's the same autocannon that they use on the Bradley fighting vehicle. So imagine, a Bradley fighting vehicle, just the turret of it mounted on your ship, and you've got, one port, one starboard in some cases. In some cases, it replaced the Mark 13 missile launcher after 2003. It's a 25 millimeter autocannon and shoots 500 rounds per minute. It has several different firing rates. 500 rounds per minute is just one of them, and the highest one. Okay, light airborne multi-purpose system. This is the LAMPS that we talked about. The LAMPS is a system installed on these helicopters. So obviously, the SH-60 Bravo is the one that holds the LAMPS 3 system, but the SH-60 in general can do a multitude of other things. But the LH-60 Bravo is the one with this system installed on it. It's a surface search and ASW capable system that allows the helicopter to go outside the radar range of the host platform, the Oliver Hazard Perry frigate, and perform long-range searches in these areas. It can also prosecute ASW targets. That's the other mission of it. So it gives the OHP class a lot of flexibility in its escort role. It can maintain a high speed, keep up with these supply ships as they're racing across the Atlantic to reinforce Europe, and provide ASW capability along the way. Again, the SH-2F Sea Sprite were deployed on short-haul frigates. The SH-60F is employed on long-haul frigates. And something interesting about the long-haul frigate is that it has this helicopter recovery assist securing traverse system, also known as RAST. Now, this is only on the long-haul ones, the ones with the Seahawks. And what it is the Seahawk can drop down a cable with a little hook on it, and a crew member, as it's trying to land, a crew member will run out onto the fantail with a cable from the ship. And here you can see the cables there below decks as they run up these pulleys topside. And he'll attach a cable from the RAST system to the cable being lowered by the helicopter. And once they're attached, an operator working in communication with the pilot can reel in or winch in the helicopter onto the pitching and rolling deck of this relatively small ship. So even in high seas, they can conduct ASW operations because they can recover these helicopters using the system, not have to rely on pilot skill and a little bit of luck or good weather. This gives them all weather capability. The LM2500 Marine Gas Turbine Power Plant. This is a marine version of the TF-39 jet engine used on DC-10 airliners. Yeah, so essentially, this is a DC-10 airline power plant that they've just put in a box and modified to fit inside a ship. It's kind of a brilliant design. It's a great idea. So a single turbine allows speeds up to 25 knots. If it runs 2, it can get up to 29 knots. The cool thing about the turbine that's better than steam-powered plants in other warships of the time is that it can get up to speed in 10 minutes. It doesn't need to generate a lot of pressure in a boiler to get the steam engines going and all that stuff. No, this thing, you turn it on, it warms up, it's ready to get underway in 10 minutes, which gives them, rapid capability to get into the fight if they need to from port. It has a low maintenance design. You know, these are designed to be easily maintained, and it's also easy to replace because it's modular. They can pull the whole thing out in a shipyard and fix it or put a new one in. Very plug and play power plant. Here's a closer picture of the LM2500 gas turbine engine on the left there. You see one of the maintenance techs working on one of the chambers there. On the right-hand side, you can see the control panel that controls each one of these. They have two installed, a port and starboard one, that both turn one shaft. All right, so the single shaft with variable pitch propeller is a very interesting design. The propeller has 5 blades, as you see here. The shaft turns at 41,000 horsepower. It can reach speeds up to 29 knots, but each blade is pivotable. So now they wouldn't normally pivot one blade and not the others. You're pivoting all the blades so they all grab the same amount of water. That way you don't shake the shaft apart. But the fact that they can control the pitch of these blades means that it will control the speed of the ship at different RPMs. So they could run, say, a fuel economic, RPM of whatever RPM. And then if they want to go faster, they can control the pitch to grab more water without changing the shaft RPM. And they can control the pitch to grab less water and slow the ship down while maintaining the same shaft RPM. Now, from a sonar perspective, this gives us a little bit of a problem because part of the way sonar estimates the speed of a contact is by its shaft RPM. Well, whenever we were tracking the Perrys and some other ships, by the way, and that had this capability, we could not rely on shaft RPM. Now, a lot of times they got lazy and they never adjusted the pitch at all, and it was very easy to estimate their speed. But whenever they would operate this mechanism, we could not rely that they were making turns for 10 knots, but in reality only making 5 knots. So they could look like they're transiting when they're actually doing an ASW search or helicopter operations. This was more than just an economic feature. This was a tactical feature of the ship and very effective at deceiving tracking submarines. Here's a close-up of the pivot points on the shaft. This is with the blades removed, and you can see how each blade is bolted on with those 8 or 9 bolts there. And that whole circle that it bolts onto, that's what rotates, pivoting the blade of the screw. It also had 2 auxiliary propulsion plant units. These are electric motors that drop down and spin, 2 3-bladed electric motors. This is how the USS Stark got back to Bahrain after it was attacked. They could not use their main engines anymore, so they used these auxiliary motors to push them back to port. So it did return to port under its own power. They can make approximately 5 knots. That's being generous, probably closer to 4. They're not meant for primary maneuvering. They're meant for getting home in an emergency. They can also be used in port to help maneuver away from the pier. So I told you the OH Perry can get underway in 10 minutes if it needs to. It's highly likely that if it's in port, say Mayport Naval Shipyard, just as an example, and the call to go to sea to defend the port is made, get underway immediately, you're probably not going to have a tug within 10 minutes to pull you away from the pier. So they could use these in that emergency situation to push them safely away from the pier and then maneuver normally throughout the channel. Oh, and these can be rotated too. This is very important. Once they're fully lowered like this, they can pivot left and right. Okay, here's some engine and auxiliary spaces of the Perry class. Here you can see some of the fuel oil chambers here. Those are the filters there. They have a gear system up overhead. That's where you take the turbine torque and apply it to the shaft. There you can see what looks like the shaft in the middle there with the gears from one turbine feeding one side of it and the gears from the other turbine feeding the other. The turbines are independent, by the way, if I haven't mentioned that. You could run on one turbine and save yourself some fuel and still make about 25 knots. All right, so some design problems that they had with this ship was because they were cutting costs and building the ship on a strict budget, they were literally designing it to the budget, seeing how much they could get into it for a fixed price. The design that came off the computer printer when they designed this thing was designed to hold 3,600 tons. But by the time they got all the crew members and equipment on it, it ended up being 4,100 tons, and they didn't change that. They didn't do anything about that. So that made it a little bit unstable while underway. It was kind of heavy, top heavy for its design. But this had the, indirect effect of making it really maneuverable too. Like the more unstable your airplane is or any vehicle, the more on the edge of stability that it is, the more maneuverable it is. Because maneuvering is breaking the stability of a continuous course. So she was designed to be maneuverable, and she was. However, there were some serious problems with the hull in the early builds of the Perry. And this was fixed almost right away. But in the first couple builds, they found cracks along the hull up to 70% of the total length of the ship. And some of these cracks were going all the way through the pressure hull, or the hull itself, not pressure hull, and could cause flooding inside the ship. So that had to be reinforced. During the first maintenance period of the earlier builds, they reinforced the hull with welds on the inside to keep this from happening. And they had to do a redesign on future builds to keep that from happening on further builds. Some midlife modifications happened in the 2000s. One was that Mark 38 Bushmaster chain gun I told you about. They added a Kingfisher mine avoidance capability to the SQS 56 sonar system. So they had the SQS 56 the whole time, but I guess they didn't get the Kingfisher mine avoidance for whatever reason until the 2000s. And that might have just been an upgrade too. But either way, they had it after the 2000s. The Caterpillar Model 3512 Bravo marine engine is installed. This helps maintain power and is much easier to maintain and is a lower cost than the older Detroit diesels that they were using for auxiliary power. Those diesels weren't even being built anymore, and they were two-stroke engines. They were a mess to maintain, expensive to operate. Well, they just ripped them out after the midlife operation and installed these Caterpillar ones that were much more modern, more fuel efficient, four-stroke, just better all the way around. They had reverse osmosis freshwater system, which is really good for the crew. And it's also good for the environment. The ventilation system, which was a real problem in the early builds, was increased to add more air going to the engineering spaces, because whenever they were operating in mid-Atlantic latitudes and like in the Persian Gulf where it's just blisteringly hot in a hot engine room, these crew members were suffering from heat exhaustion in some time. So they increased the amount of flow of air through the engineering and auxiliary spaces. And they also added the SCBA firefighting gear. Now, this was a Navy-wide thing in the 2000s. We got the Scott air bottles, even on the submarines, but it was a big improvement over the old OBA firefighting breathing apparatus that we had that had like 1960s technology and was kind of dangerous because the candle that you held on your chest that fed your mask oxygen, it got really hot. So you had essentially a heating pad on your chest as you're going in to fight a fire. Not exactly safe. Plus it's making pure oxygen. That's not good. Anyway, I digress. Okay, export variants. Now there's lots of different export variants of this. So we're just going to briefly go over these. Australia operates 6 of these Adelaide class. Remember, 4 were the short haul. They added the Mark 41 VLS, shooting the Evolved Sea Sparrow missiles forward of the Mark 13 launcher. So that was a large increase of its offensive capability. And Turkey followed suit. They did the same thing. Spain operates 6 of these. They call them the Santa Maria class because they are modified. They're slightly wider. They can take on the weight of the 4100, adding stability to the ship. And they have improved electronics as well. So basically, these other countries like Australia, Spain, and Taiwan, they're taking the basic design and correcting some of its faults and adding some of their own equipment on board. Like in Taiwan, they added the they added the HF-3 supersonic missile, anti-ship missile, and called it the Chang Kung class. Also added a new fire control system because they needed the fire control system to operate the new supersonic missiles that they're shooting. Turkey basically put in their own indigenous system called the Genesis Combat System, operating the Smart S Mark II radar, and, like the Australians, added that Mark 41 vertical launch system that carries 32 Evolved Sea Sparrow, almost doubling its anti-air capability. So a very good mod for them. Chile ends up buying 2 of the Adelaide class from Australia in 2019, and those are in operation today. Other countries around the world are also operating the OHPs, like Bahrain, Egypt, Pakistan, and Poland all operate these still. So a very robust design, 50 years after its original development, still seeing service today. Let's go back to the tanker war. April 1988. This is less than a year after the Stark incident. The USS Samuel B. Roberts is on patrol in the Persian Gulf when it strikes a mine, an M08 naval mine, which is one of the old ball-shaped mines with the pointy ends sticking out of it. It blows a 15-foot hole in the bottom of the ship, cracking the keel into 2 different pieces. Anytime you crack a keel of a ship, the ship should just wrench itself apart under its own weight, because the keel is the center point on which the entire ship balances itself. So with the keel broken, though, the crew ingeniously grabbed some cable, and I don't know where they got this cable from, but they got cable wire, and they wrapped it around the hull. So around the bottom, up over the top of the superstructure, and then around again. And they made several revolutions of this cable, literally holding the ship together, giving what was left of the keel enough strength to get back to Bahrain, where it could get some repairs and dry dock and make its way back to the States for full repairs. So, and again, it got underway after the attack of the mine, or after the damage of the mine, with its auxiliary motors, those little drop-down pods that make about 5 knots. That's how it got back to Bahrain, just like the Stark did not too long before. So again, just a great example of how strong this little ship is. It can absorb some damage. It's taken 2 exocets, and this one has taken a mine hit, blowing the keel into 2 different halves, and did not sink. All right, so my final thoughts. Obviously, I've foreshadowed this. I'm really impressed with the durability of the Oliver Hazard Perry. If you put this ship in a fight with a well-trained crew, and you turn on its weapon systems, it's going to be very formidable. So well-designed ship, very durable, purpose-built for escort missions. I mean, this is not a standalone, go into a battle and support itself. It's designed to escort ships through places like the Persian Gulf, Straits of Hormuz, or across, deep water like the Atlantic and Pacific Oceans. It can do both. It is used when it's with a fleet as a picket ship. You'll see these ships on the outside of the fleet, furthest away from the aircraft carrier, being responsible for that sector air defense and ASW operations. It has a very short sonar range compared to the Spruance and other medium frequency sonars. So that is kind of a liability of it, but because it has the lamps, helicopters that can go out dozens, of miles and do an ASW search on the outer perimeter of the fleet's track or ahead of the escort where the ships are going. That's not as much of a vulnerability as you may think. It highly relies on the helicopters to interrogate detections. The lamps program was added scout value because the lamps also included surface search capability. So while this is a radar picket ship, essentially, when it's in fleet operations, the helicopters can run out in any direction and search for ships and get visual identification on things before the whole fleet gets to it. So it adds a lot of different roles and capability when it's working with the fleet. But you wouldn't want to take this into a large battle as a standalone. Think about that Mark 13 launcher loading every 8 seconds. You're probably going to get 1 or 2 missiles off if you're being attacked before the missiles actually reach you. So if they shoot you with, say, 4 or 5 missiles, you're not going to have the anti-air reload capability to shoot down all those missiles before they get within terminal range of you. And you do have systems like the CIWS, and even that Mark 76 gun can shoot at incoming subsonic missiles, but they're not nearly as reliable as, say, the SM-1 doing a missile kill. Also, the Harpoon reload time of 22 seconds is pretty bad. You're not going to be able to launch enough harpoons in a short period of time to overload another modern warship's defensive systems. If the target you're shooting at is only seeing one missile coming at it every 22 seconds, that gives that target lots of time to prepare and maneuver and get in position to defend itself from one missile at a time. The idea of modern naval warfare is to first overload the communication and network data links, and then once you've done that, you've stripped down each ship to just its individual parts, be it the CIWS or even that Mark 13 launcher, and then you overwhelm that with 4 or 5 missiles in a short period of time. Well, if this was operating by itself, it simply can't launch enough missiles fast enough. But when it's with a fleet and it's working as a team, being coordinated with other frigates or better ships, it can be very formidable. So it's all in how you use it. All right, that's it for the O.H. Perry warship brief. This is my very first one doing this. I hope you really liked it. I want to say thank you very much to the extremely generous support of the Wardroom, Department Heads JB, William R. Collier Jr., Swiftdraw, and we're welcoming into the Wardroom for the first time. Everyone give it up for Stefano Mariani. Thank you, Stefano. You guys are the best.